Yeah, hi and welcome to a new video on my channel, or well, the first one that is about electronics. In this video we want to build our own Makita battery pack. That's nothing new, but this pack in general supports 21700 cells, so most of the packs you find on AliExpress or Alibaba and so on are made for 18650 cells. And these ones, or there are some types of 21700 cases, but I chose that one. There are, as I said, a few variations, mostly just the BMS is slightly different. And yeah, these are the 21700 cells. They are a little bit larger than 18650s. I don't have any to compare them against, but they are way bigger. I can show you in comparison one with 18650, so ready to go battery pack. So that is one. Well, I got the same configuration, so 5 cells in series and 2 in parallel, so 5 S2P. And I already got the already made battery pack with 21700 cells here. And as you can see, it's quite larger, like from lengthwise and from the thickness. A little bit, yeah. But it's way heavier, so it's like 900 grams and that's just 600 grams. So to summarize everything, we see here a schematic of the BMS and the cells. And we see that we got 5 cells in series and 2 in parallel. So we got a 5S2P configuration. Why 5 in series? That's pretty simple, because 5 times 3.6 volt, the typical voltage of 18650 or all other cells, or in our case 21700 cells, is 18 volts. So the default voltage of Makita LXD batteries. And how do we know our capacity of the battery pack? That's also pretty simple, because we have 2 groups in parallel. We can just multiply it by 2, our capacity of 1 cell, so that's 4 amp hours. So we got an 8 amp hour battery at the end. And because 8 amp hour is a pretty bad metric, we want to have watt hours. Watt hours are simply, you multiply the voltage by the capacity in amp hours, and that is 144 watt hours. And that's, in my opinion, a pretty beefy battery pack, because with 2 times 5 amps, because again parallel, we can output 100 amps, and then 18 volts times 100 amps is 1800 watts. So that's really good. So yeah, the cells used, so I will put that together again, because we need it in the next step. So the cells we are using are EVE cells, or EVE. This is a Chinese brand. I know Chinese battery cells are mostly not the best one, but actually with this 21700 cells they got like really good models. And from the specifications they got 4 amp hours or 4000 milliamp hours, and they got a maximum continuous discharge of 50 amps, so that's really good. In our configuration that would be 100 amps, because we are having 2 rows in parallel. So that's nice for the cells, and because we got 4000 milliamp hours, the battery at the end will have roughly 8 amp hours. I measured them and they got like 4.2 amp hours, so it's more or less like 8.4 amp hours, but depending on the load the capacity will decrease. That you can see here, like regarding the discharge, it got like at 40 amps, it only got 90% of capacity. So the first step is now to measure the internal resistance of these cells, and for that you need this one here, because as it's stated here, it's measuring it with AC with 1 kilohertz. So you need an internal resistance tester. You can get them fairly cheap at AliExpress. This one is a fancy one with a LC screen, so not with a monochrome thing or something like that. And as you can see, these probes here got 2 connections on both sides. So, and such, yeah, pogo pins. As you can see, you can push them down. And we got here the internal resistance and here the voltage, and they're fairly accurate for our use case. It's more than enough. So we will now measure every cell. $9.4 milliohms. So yeah, we saw that every cell has an internal resistance under 13 or even under 10 milliohms. So they are all good to go. So then our next step would be to use this enclosure, or you just use this case where you can like really fancy put in the cells. So they actually got markings on there how you should arrange them, so if that should be the positive or negative direction of the battery. So that should be negative, 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 and then it's just like switching because we want to build a 5S2P configuration as I explained. Now we got our battery pack, but we need to connect them. So we got here nice plates for that from nickel, or made of nickel. Then a nice sticker. We don't need it now. And for connecting it, we need to use a spot welder, because with soldering you would just get the heat into the cell and it can damage it or even destroy it, and then it can explode, so you need a spot welder for that. Theoretically, with enough practice you can do it just with soldering, but that's the way a safer method, and they are not really that pricey, so you can get these at Amazon or AliExpress for like 20 to 30 euros. So yeah, now we are just connecting the batteries. So basically now they are soldered together, and you have to do that now with every cell. So now the spot welding job is done, and we have to connect the BMS. So now the soldering job is done. It's not perfect, but yeah, I need to practice soldering a little bit. Yeah, but it works, our indicator. Now we have to build it into our case, that it's protected and nicely enclosed. Oh yeah, first of all we need to clip that in. Yes, so now our battery pack is finished. We can at the end check if the voltages are correct. Well, you should probably do it before assembling it, but yeah, 20.9 volts. That is like an 18 volt battery completely charged, as you can see. All 4 bars. Then we can attach the sticker. Yeah, call it a day. Now we have a nice Makita battery that has more capacity than the original 5 or 6 amp hour one, and even more juice, so it could output 100 amps at 18 volts or now 20 volts. And it works. Nice, right?